Hello everyone, so today I'll be covering question number 31 of GATE 2013. All the members in the rigid jointed frame shown are prismatic and have the same flexural stiffness. Find the magnitude of the bending moment at Q in kilonewton meter due to the given loading. So here we have this 100 kilonewton meter moment applied at this joint T, and we need to find the bending moment at this position Q. For this type of lecture, you can refer to lecture series on Structural Analysis 1 by Professor Amit Shaw, Department of Civil Engineering, IIT Kharagpur. It's a 2-mark question of fill in the blanks type. Let's start with the solution of this problem. So here we have this 100 kilonewton meter moment which is applied at joint T. So this moment will be distributed to the members PT, TR and TQ according to the distribution factors. There will be no moment shared by this member ST because it is unsupported. So let us first calculate the distribution factor for different members. So how do we define the distribution factors? Distribution factor is defined as stiffness of that particular member divided by the stiffness of total stiffness at the joint. So here we have the members PT, QT and TR which are connected at T. So first of all, let's find out the stiffness of different members. So let's take up this member QT first. So stiffness of member QT will be, since the far end of this member TQ is fixed, therefore stiffness, we will calculate the stiffness as 4 EI by length of this member QT. So for this case, length of member QT is 2, so 4 EI by 2, or we can say that KQT, that is the stiffness of member QT, will be 2 EI. Similarly, if we want to find out the stiffness of member TR, so the far end of this member TR is fixed, therefore KTR will be equal to 4 EI divided by length of TR. Length of this member TR is 4, hence we can say KTR is EI. Now let's find out the stiffness of member PT. So far end here is pinned, so it will be 3 EI divided by length of PT. Length of PT is 3 meter, so KPT comes out to be EI. So in our formula to calculate the distribution factor for different members, we have the stiffness of that particular member divided by the total stiffness at the joint. So now we know the stiffness of all the connected members, so let us find the total stiffness at joint. So total stiffness is KPT plus KTQ plus KTR. So it will be EI plus 2 EI plus EI. So total stiffness, K total, we can write it. So K total we got as 4 EI. Now we can calculate the distribution factors of different members. So let's find out the distribution factor for QT. So distribution factor for QT member will be equal to the stiffness of member QT, which is 2 EI, divided by total joint stiffness, which is 4 EI. So from here we get the value of distribution factor for QT as 0.5. Right. Now, since we need to find out the moment at Q, we need not find the distribution factors for other members. At this point, we know that the moment shared by this member QT will be 0.5 times this total 100 kilonewton meter load or moment. So the moment at this member will be 0.5 times the total applied moment, which is 100. So it is 50 kilonewton meter. Now we know that the carryover factor for a fixed end is 1/2. So here we need to find out the moment at Q. So if we apply the moment 50 kilonewton meter here, the moment carried over to this point Q will be half of the applied moment. So this will be, the moment at Q will be equal to 25 kilonewton meter. So we needed to find the moment at Q. So our answer is 25.